Okay, guys. So we're gonna um continue with the trig. But today's class is gonna be slightly challenging. So I hope yesterday's class made sense. I'm not receiving any emails. Usually that's a good indication, but I'm not too sure what's happening, right? So if you are confused, please let me know. So my starter question for today's class, right? I'm gonna ask you to pause the video, do this question, is based on yesterday's class. So hopefully you can get this done. Um, and if I'm not mistaken, I think I've chosen this question from the textbook. Okay, so for those of you who are doing your homework and you're doing all the questions that I'm assigning, you can kind of skip this part, I guess. If if you're getting the right answers. If not, then I really want you to pay attention over here because if you're not getting this, you're not gonna get anything in today's class. Okay, so again, think about math is it builds on, right? So don't be shy. As soon as you have a question, just shoot me an email and then we can, schedule a webinar, right? So I know that I'm scheduling a webinar on Thursday, um, but I don't want to wait until Thursday if my students are already having problems, right? So just give me a heads up and I'm willing to do more than one per week, but I need to know if students, you know, would actually benefit from that. Okay, so send me an email and then we can arrange something. Okay, so let's quickly do this question, right? So we're looking for the ratios sine, cos, and tan. So when the point is given, right, just draw a Cartesian plane. So I'm just going to remove everything and plot your points. Okay, so this is x, this is y. My first coordinate is x, my second one is y, right? So x is actually, let's extend this a little bit. X is, you know what, let's just leave it like that. So I can scale it however I want, right? So minus 24. I'm just gonna put this on top. And my y coordinate is minus 10. Okay, so that means my point is somewhere over here, right? Minus 24, minus 10. Now, to find the terminal arm, all you have to do is connect this point to the origin, okay? And then you have your terminal arm, okay? But we're going to be making use of the reference angle. So to get the reference angle right, connect this point to the x-axis, and then this would be your reference angle, okay? So this is what will help us find the ratios because we're going to use this as guidance, okay? Because now our triangle is kind of set up. Um, and but what you have to remember is that what we're really interested in is this ratio over here, right? This angle over here. So let me just draw this a little nicer. So this is your actual data, okay? But it's kind of difficult to figure out SOHCAHTOA with this angle because you can't really draw a triangle. So we're gonna use the reference angle as um, guidance. Okay, so this is my if you want, the height of the triangle, so this is 10. Again, I want my length to be positive all the time, and this will obviously be 24, okay? And making it positive will make sense in today's class. I know the textbook does it a little differently, and if you're following the textbook, then um, you know, if you do it the way they are doing it, yesterday's class would have been slightly easier, but today's class is going to be difficult. Okay, so my recommendation, just keep it positive and then, just be consistent with that. Okay, so anyway, so I have my two legs of the triangle, but because I'm going to have to use SOHCAHTOA, I will need to figure out what my hypotenuse is, right? So let's just quickly do the calculations up here. So 10 squared plus 24 squared is actually equals to c squared, right? So this, because it's a 90 degrees, right? So this has to be the side opposite to 90 degrees is your c, okay? And then you can, do algebra and solve for c. I'm actually not gonna write everything out, but C is just going to equal to um, 10 squared plus 24 squared square root. And when you take the square root of this, you will get an exact value, I think, because it's arranged in such a way. So 10 squared plus 24 squared, and then you take the square root, it's 26, okay? So your C value is 26. Now, once you have your C value, it's just a question of using SOHCAHTOA. Okay, so let's start off with maybe in red. So sine, right? Again, I'm going to be consistent with my colors. So I'm actually interested in this data, right? My standard angle, okay? So sine theta is using SOHCAHTOA, right? Is equals to O stands for opposite and H stands for hypotenuse, right? So the side opposite to my angle is 10, right? And my hypotenuse is 26, okay? So the reference angle, right, is nice because it guides you, um, but you have to be careful because it will give you the right ratio, but you have to kind of like manually insert a negative sign, and the picture will tell you if you have to do that or not, right? But because this point is the y coordinate of this point is negative, so my sine ratio has to be negative, okay? And you can figure out cos in a similar fashion, right? So let's do this in blue. So cos, again, I'm going to be consistent with my theta. Theta is equals to adjacent, right? So this is my theta r. Adjacent to this is 24 um, over my hypotenuse, right? So it comes from here, right? A for adjacent, H for hypotenuse. So 26. And again, I'm just going to erase my equal signs. Free some space up because as you can see, this point, right, this point that you have, the x coordinate of this point is negative, right? So your cos ratio also has to be negative. Now tan is slightly tricky, so let's go with green for tan, right? So tan is just opposite over adjacent, right? So tan is equals to, if this is my reference angle, the side opposite to that is this side, 10, and adjacent to that is this one, 24, okay? Now, because my sine is negative, my cos is negative, and tan is sine over cos, the negatives will cancel out and this will be positive, right? Another way of thinking about this is because your point is in the third quadrant, it has to be positive. Okay, so because tan is positive in the third quadrant and in the first quadrant, okay, from yesterday's notes. So I guess one more thing that you could do, I'm not going to penalize you for this, but you could maybe simplify your fractions. So if you divide by 2, then this becomes minus 5 over 13. This becomes minus 12 over 13. And this will just become 5 over 12. Okay, so you can simplify your ratios, not a big deal. I don't know how your textbook does it, but yeah, that's something that you could do. Okay, now today's class is, like I said, today's class is challenging because today what we're gonna do is we're gonna give you um, the value of sine theta, which is zero point 0.5, and then we'll ask you to find theta. Okay. So this is tricky, guys, because just like the quadratic function, when you're solving for sine and cos, and your domain is between 0 and 360, then you're going to have two solutions. So if you use your calculator to figure out the answer, you're only going to get one of the two answers, okay? Because your calculator is not that smart, okay? So you kind of have to do this yourself and not rely on the calculator over here. So how do you approach a question like this? Again, we're going to start with the Cartesian plane. Okay, so the Cartesian plane will help us find the two solutions. So for sine and cos, there will always be two solutions. There's actually infinitely many of those, but because your domain is restricted between just 0 and 360, you're going to have two, okay? Okay, so in 30-1, you're going to be doing a lot of this. And technically, you can have more than two solutions. It depends on, yeah, it depends on the coefficient of theta if you want. Okay, so that we're not going to have that in 20 dash 1. Okay, so let's just stick with the basics. Hopefully this will make sense. And then when you take 30 dash 1, then with the foundation that you have from this class, it will be a little bit easier to follow along. Okay, so remember, the trick over here is I'm gonna ask you to consider sine as your y coordinate. Okay, so sine has to be your y coordinate, and it is your y coordinate if you choose your radius or to equal to 1. Okay, so that's what we're gonna do. Now, this is telling me that my y coordinate is 0.5, right? So I have a point. This is giving me a point. So my point is at 0.5. So my point is at 0.5. So my point could either be on the right side or it could be on the left side because both of them have the same y value of 0.5. Okay, so once you have your point, just like I've always said, connect your point to the origin, okay? And do the same with the other one. Connect your point to the origin. So these are your two solutions. Now, connect the point to your x-axis to form a right angle triangle. And when you do that, both those triangles are identical, by the way, okay? Because if you don't believe me, let's just work this out. So I know that this value over here is, let me use a different color, okay? Because I see a lot of reds. This right? Height of the triangle is 0.5, and I have asked you to use r is equals to 1 for your, so that means your hypotenuse is 1. Now, in every question, that will be the case, okay? And this is a trick that works, and let me explain why. Because remember, let's just find this angle over here. So let's just call this theta r, okay? So sine, right? So using SOHCAHTOA, let's just focus on so means sine theta r is equals to opposite, right? What do I have on the opposite of this angle? It's 0.5. And what is my hypotenuse? It's 1, right? So which is what my question is, um, which is what my question has, right? So I'm just arranging my triangles in such a way that it respects the questions, okay? So if you choose your radius to be 1, and then you choose sine to be your y coordinate, it will work. Okay, if you choose your x to be your cos theta to be your x coordinate, and you pick your r value to be 1, it will always work. Okay, so that's why, remember, r has to be 1. Okay, this is the key over here. Okay, so I have created a visual image of what the question is asking me, essentially, okay, by doing all this. Okay, so once you have your picture set up, what you need to do is, once you have this, right, so once you have this picture to help you with the answers, you're good. Okay, so now what you have to do is just focus on grade 10 math. Okay, so what I'm gonna do is, using this picture, I'm actually gonna solve for my reference angle. Okay, so shouldn't have erased that, but let's rewrite it again. So sine theta, but I'm going to use my reference angle. Okay, so by the way, this is also theta r, okay, because this height is also 0.5. And because I've always asked you to consider your lengths to be positive, right? It's essentially the same triangle, because this length and this length, they're equal, right? And because I'm asking you to use positive values, right? They're exactly the same. So but yeah, so let's just find the reference angle first, and everything else will make sense. Okay, so let's just erase this. So I know that sine theta is equals to, right, using SOHCAHTOA, it's opposite, so 0.5 over my um, hypotenuse, which is 1, right? So you see, you don't have to put the 1, right? Because if you divide 0.5 by 1, you still have 0.5. Now, how do you solve for r, right? Using grade 10 math, right? You just take the inverse sign on both sides. So the inverse sign will cancel the sine value, right? And then what you will be left with is theta r, and this is equals to inverse sine of 0.5, which will be an angle, right? So whenever you take the inverse sine, it gives you an angle. So how do you use this in your calculator, just use the shift. At least that's what my calculator does. You know what? I'm actually gonna pull out the calculator that you guys are using. Make sure that it's in degree mode, okay? Because if it's not, then in radian mode, you're gonna get weird numbers that will make no sense, okay? So if you use the second function and click on sine, you will get sine inverse, and then just put 0.5, close the bracket, and that will give you okay, so I am not getting what I'm supposed to be getting because my calculator is in radian mode. So click on mode, and then it's the second one, right? So change the radian to degree, and then click enter, and then I guess clear this. So let's try this one more time. Sine so shift sine 0.5, and that gives you 30. Okay, so 30 makes sense because it's 30 degrees. And once you have this, you essentially have your answer. Okay, so remember, your answer will always be the standard angle. Okay, so we are interested in there's two solutions. The first one um, is this angle over here. Okay, again, it starts from 0, so we're interested in this angle. Okay, I'm going to call this theta 1. Okay, that's theta 1. That's the first solution that I'm interested in. The second one starts again from, it always has to start from 0, right? So remember, this is 0 degrees, and you have to go all the way up to your terminal arm. Okay, so this, I'm going to call this theta 2, okay? So theta 1 starts from here, goes to the first terminal arm. Theta 2 starts from here, goes to the second terminal arm. And we need to figure out what those values are. Now, if you look at the picture, it turns out that theta 1 is equals to your reference angle, right? So theta 1 is equals to theta r, which is equals to 30 degrees. So that's your first solution. Now, your second solution is um, maybe, you know what, let me just use a different color so that I can distinguish the two thetas. Okay, so I'm not gonna use purple for this one. Let's go with something else. Okay, let's go with green. So you start from the 0, right, and go all the way up to your second um, terminal arm, and let's call this theta 2. Okay, so how can you figure out the value of theta 2? Well, you know that this arm over here, right, is at 180 degrees. And you know that, you know the value of your theta r. You just figured it out, right? So this is using this fact over here. This is 30, right? So I know that the whole thing from here all the way up to here, right, is 180. And I know that this piece over here is 30 degrees. So you're just going to take the difference. Okay, so it's starting to look ugly, but it's just 180. So it's just this angle minus this piece over here, which is 30. So theta 2 will actually equal to 180 minus 30, which is equals to 150 degrees, okay? And now you can check your work. So these are your two solutions, theta 1 and theta 2. So just like the quadratic function, there are two solutions. And usually when there are two solutions, students get confused, okay? So how can you check that this is the right answer? So now let's just check. So I'm claiming that if my theta has the value of either 30 or 150, I'm gonna get 0.5. So let's check. Let's do, so this is where I'm gonna check. So sine of 30, so sine, oops, I'm gonna be consistent with my colors. Okay, so sine of 30, if you use your calculator, does that give you 0.5? Sine of 30, yes, it does, right? It gives you 0.5. Oops. Uh, sorry about that. So I'm running out of space over here, so it's kind of like difficult to write that. So sine of 30 does give me 0.5. Now let's check if sine of 150 gives me 0.5. So use your calculator, calculate the value of sine of 150, and check. Does sine of 150 give me 0.5? Yes, it does. Okay, so that's how you find your two solutions. I know this is kind of hard, guys. Okay, so this is trig is what the students struggle with the most in 30-1. But if you draw a picture the way I did, then the picture will tell you everything that you need to know. Okay. So start with the picture. So let's do one more question. Okay, let's do one more question. Cos of negative square root of 3 over 2. So remember, cos, I have mentioned this yesterday, right? I want you to treat cos as your x value. Okay, but when you treat your cos as your x value, that's only possible when your radius is equals to 1. Okay, so in other words, for every single question, just treat your cos as your x value, sine as your y value, and make sure your radius is 1, and then it will work out. Okay, so let's do the Cartesian plane. Okay, so we have the Cartesian plane, x, y. Now they are telling me that my x coordinate is at negative 3, negative square root of 3 over 2. This is where my x coordinate is, right? So, but the problem is, because my x coordinate is over here, my y coordinate could either be positive or my y coordinate could be negative, right? So both of these dots have the same x value, which is minus square root of 3 over 2. So you see, you're going to have two solutions. So you're going to have two dots, just like in the previous question, you had two dots, okay? Because both of these dots have a y value of 0.5, okay? Now here, both of these dots have an x value of minus 3 over 2. So once you have your two dots, connect them to the origin. So this is your first terminal arm. So this will be your first solution. And this is your second terminal arm, okay? And both these triangles are identical. So just connect both of the dots to the x-axis. Okay, so how should I do this? So maybe let me just erase this, okay? And let me just connect this dot to the x-axis. And then I am just going to write this separately, okay? So to point out that this coordinate is actually minus square root of 3 over 2, okay? So if this x coordinate is minus square root of 3 over 2, then that means that this side length, right? The length of this side is square root of 3 over 2. Again, I want you to consider your side lengths to be positive, okay? And my radius is 1. This is the same radius. This is also equals to 1. So you need to find the reference angle, okay? So the reference angle is the angle between the x-axis and one of your terminal arms. So you could call this theta r, or you could call this theta r. Both of them are the same, okay? Because it's the same triangle. They have the same sides, right? So the hypotenuse is 1, the hypotenuse is 1. Both of them have a base value of square root of 3 over 2, okay? So what are my two solutions? My two solutions will always be the standard angle. Okay, so standard angle starts at 0 degrees, which is this, right? So my first solution will start from here and go to my first terminal arm. So that's theta 1, okay? And my second solution, if you want, will start, let's just, just, yeah, let's just do it this way. Okay, so it's going to look really big. But you know what? I'm just gonna do it this way. So my second, again, it has to start with at 0, right? And then it has to go all the way to the second terminal arm. So that is theta 2. Okay, so we need to figure out what theta 1 is and what theta 2 is. And before we can figure that out, we have to figure out what the reference angle is. And that's not too difficult to do, because this is just grade 10 math. Okay, so let's just focus on the top triangle. On top over here, this triangle, right? I have this triangle over here. My hypotenuse is 1. This is my theta r. And my base, if you want, is square root of 3 over 2, right? So if I have two of the sides of the triangle, I can actually calculate the angle, right? So I know that cos theta is equals to, right, using SOHCAHTOA, so cos is ka, adjacent over hypotenuse, right? So adjacent, which is this side, over hypotenuse. So cos theta is square root of 3 over 2, okay? Now I'm going to solve for theta. So theta is just equals to the inverse cos of square root of 3 over 2. And when you do that, right, make sure your calculator again is in degree mode. So square root of 3 divide by 2, okay, you get 30. Okay, so theta r, so maybe I should have put that. Theta r is actually equals to 30 degrees. If theta r is equals to 30 degrees, then what is theta 1 equals to? Because theta 1 is my solution. So theta 1 is this over here, okay? I know that the whole thing from here all the way here, oops, from here, if I go all the way here, this is 180, right? This is 180, and now I know the value of this angle, it's 30. So theta 1, right, I'm just going to erase that. So theta 1, by looking at the picture, is just equals to 180 minus 30, okay, which is equals to 150 degrees. Theta 2, so theta 2 starts from here, goes all the way there. I know that this much, right, from here. So let me use another color. So let's go with blue. I know from here to here, right, this is half the circle, so this is 180. And then I have to add this extra piece to get theta 2. Okay, so theta 2 will be equals to, so theta 2 will equals to 180 plus my reference angle, right? So plus 30, which is equals to 210 degrees. Okay, so these are my two solutions. And again, you can check your answer, right? So use your calculator, find the cos value of 150, and you're going to get minus 0.866, which is minus 3 square root of 2. Remember from yesterday, right? I told you once you get 0.866, the exact value of that is the exact value of 0.866 is square root of 3 over 2. Okay, so for cos of 150, you should get minus 0.866, and in a similar fashion, you're going to get, so let's calculate cos of 210. That value will also be minus 0.866. Okay, so you can check your work this way. I hope this is kind of making sense. This is hard. 30-1 students sometimes struggle with this. Okay, and the best way of doing this question is, again, to treat your cos value as your x coordinate, right? Make sure your radius is 1. Draw this out, so you're gonna have 2 points, right? This one over here, because both of them, these 2 points, both of them have an x value of negative square root of 3 over 2, right? And then draw the triangles, find the reference angle, and then you're gonna use the reference angle to figure out what theta 1 and theta 2 are, okay? Here I'm removing the reference angle, here I'm adding it. How do you know when to remove, when to add? The picture will show you, okay? So once you draw the right picture, the picture will show you what needs to be done, okay? So you know what? I think this is getting slightly difficult. So I am gonna ask you to do this question on your own, okay? And I'm gonna stop here. Okay, I'm gonna stop here because I had 2 more questions, but I think this is gonna take longer than I had expected. Okay, so do this question, pause the video, try doing this one, and then I'll show you the solution of this, and then I'll stop my video. I think it's getting really long. Okay, so sorry about that, but I know that this is a difficult class. Okay, so I'm really taking my time. So pause the video, try this. I'm going to proceed. So draw a Cartesian plane, right? Sine theta is my y value, right? So this Cartesian plane is telling me that my y value is negative. So it's minus 1 over square root of 2. Okay, so my y value will be negative if the dot is either here or here, right? Both of them have the same y value. but one of them has a positive x value, the other one is negative, right? So you're gonna have two dots for sine and cos, okay? Both of them are at the point y is equals to negative square root of 1 over 2. So once you have your two dots, make sure you're connecting them to the origin, okay? So these are your two terminal arms, okay? And then connect them to the x-axis, okay? So x, y, maybe I should label it, right? And now you have your triangle, okay? Again, because I'm assuming y to be sine theta, that means that my radius is 1, okay? So radius is 1, radius is 1, right? By radius, I mean your hypotenuse, right? So this length is 1, and this is, again, length. I want you to consider the length to be positive, so 1 over square root of 2. You know what? Let me just use different colors, okay? Because I don't know. I find it difficult to visualize when I see the same color. So this, right, is 1. This is 1. This length over here is 1 over square root of 2. This length over here is also 1 over square root of 2, okay? So I'm going to find my reference angle. Reference angle will be the angle between the x-axis and the terminal arm, so theta r. This is also theta r, right, because they're the same triangle, okay? So theta r, it doesn't matter which triangle you're looking at, so let's just focus on this one. So SOHCAHTOA, right? So because you know I have sine, I'm just gonna be interested in so. So sine of my angle is equals to the opposite sine, which is 1 over square root of 2 over my hypotenuse, which is 1. So you don't have to write that. So let's solve for the reference angle. So theta r will just equal to the inverse sine of 1 over square root of 2. And when you do that, you're going to get sine inverse of 1 divided by square root of 2. I think it's 45, but let's see. Yep, 45, okay? 45 degrees. So now you know what your reference angle is, okay? But your solution will always be the standard angle, right? The standard angle always starts from 0 and goes all the way. So this is the first one, goes all the way to the first terminal arm. So this is theta 1, okay? And the second one, right? So the second one, let's just start over here. So I'm still starting at 0. And this is going to go all the way to your second terminal arm, okay? So this is theta 2. Now, how can you find the values? Okay, by looking at the picture. Okay, so by looking at the picture, I know that theta 1 is equals to, right? It's starts from here, goes all the way here. So this is 180, right? Plus theta r, right? So it's going to be 180 plus 45, which is equals to 225, I think. But, you know, I don't want to make any mistakes. So 225 degrees, okay? Theta 2 um, is slightly difficult. Okay, so theta 2 starts from here, goes um, all the way from here, right, all the way there. Okay, so your terminal arm is all the way down here. So how can you figure this angle? Well, I mean, one way to do this is just to realize that if I complete my circle, I'm gonna have 360, right? But what if I complete my circle and then remove this reference angle? Then I'm going to be over here, right? So I have to remove this piece, okay? So if I do the full circle, then I'm at 360, but I don't want to do the full circle. Okay, wow, that's a nice looking circle. I didn't know you could actually do that. I don't want to do a full circle because I'm going to have to remove this piece. So theta 2 will actually be 360, so the full circle minus my reference angle, which is 45, okay? So let me um, remove all this because it looks really ugly. Oops, not like that. Okay, so let me just remove all this, okay? So this, if you work this out, right, will be 315, I think. 360 minus 45, 315, okay, degrees. And now check, okay? So because I'm claiming that these are my two solutions. So if I take sine of theta 1, does that give me this value? So let's take sine of 225. What do I get? I get minus 0.707, okay? And if you divide 1 by square root of 2, you're going to get the same thing, okay? So now let's do sine of my second angle, which is 315. So sine of 315, that also gives me minus 0.707, okay? So I know this is kind of tricky, guys. I'm going to stop here. So on Thursday, I'm going to upload the remaining notes, and I will also have my, webinar to help you. But, again, the trick is always the same, okay? So consider sine as y. When you do that, it forces your radius to be 1, right? And then, right, you will have two dots all the time that will respect this condition, right? Draw your terminal arm, draw the right angle triangle, find the reference angle, and then use the reference angle to calculate theta 1 and theta 2, okay? So sometimes you might have to add the reference angle, sometimes you might have to subtract the reference angle. The picture will tell you when to do what, okay? So I hope this kind of made sense. If not, again, please send me an email and also come join me on Thursday so that we can have a discussion about this, okay? So I am, you know what, if you guys are feeling comfortable, um, try doing these questions, right? It's exactly the same thing, except now you're not gonna get nice exact angles. Your angles will be um, um, an approximation. So you're not like in these questions, all your angles were exact, right? Like 225, 315. Here it will be a decimal, okay? You're gonna get decimal values, but the logic still holds. So you can pause this, take a picture of that, try it, and then maybe do this question too. And then tomorrow I'll show you how to do tan. Tan is much easier, guys, okay? Tan, you don't have to draw any pictures. So, because my video I think is getting too long, I'm just gonna stop here and then post a different video separately on Thursday, okay? So I hope this is making sense, guys. Again, don't be shy. Send me an email if it's not, okay? Yeah, so I'm trying my best. I just kind of feel bad for you because this is not easy, okay? So trust me, guys, I'm doing everything that I can, but you have to meet me halfway, okay? So if you're not getting it, please show up on the webinar. I am open to having a webinar more than once a week, but I need emails to be sent out so that I can accommodate you, okay? So thank you so much, guys. I hope this is not too overwhelming. If it is, send me an email and then we can make some arrangements, okay? Okay, take care.